A tangent drawn to a circle. Circle proofs continued. Oops, continued. A tangent drawn to a circle is perpendicular to the radius. I'm just copying from up there. Whoops, perpendicular to the radius at the point of contact. Doesn't even look like a tangent. It's such a beautiful circle too. There we go. Now it looks like a tangent. O P Q R. This one's a slightly interesting proof. We're going to prove this by contradiction. Suppose this is not perpendicular. Then there's some other point here that is perpendicular. That does make a perpendicular intersection. Assume OT is perpendicular to QR. Assume the radius meets the tangent and it's not perpendicular. So let's draw another line where it is perpendicular. I know it doesn't look it. Suppose it is. We're going to make it cross here at S. It's going to cross the circle at S on the way to T. Your diagram might not be big enough. You're going to have trouble putting an S in here. We're going to do some reasoning. I'm looking at my notes for this one because I'm not very good at doing this one because it's a little bit weird. Okay. So we know PTO is 90 degrees because we're assuming it's perpendicular. And because triangles have 180 degrees in them, P and, let me do this, and this is the largest angle in the triangle, I think it's PTO, OPT. So angle PTO is 90 degrees, and it has to be the largest angle because the total is 180. So I can't have anything bigger than 90. That means angle PTO is bigger than, oh man, that's hard to get right, isn't it? Greater than, make sure my angle signs look nice, is greater than angle OPT. Now it looks like an L, angle OPT. Because it has to be the biggest angle. Now, if this is the biggest angle, then the side opposite it must be the longest side of the triangle. Do you believe that? Whatever kind of triangle I draw, the largest angle is opposite the largest side. Maybe I can convince you like this. Oh, sorry, sine A on A is sine B. You know the sine rule? Have you done the sine rule? So, the largest side has to have the largest angle. So, that means OP, the side opposite the largest angle must be the longest side. Can you see the contradiction coming yet? So this is supposed to be the largest, the longest side in this triangle. But OP is the same length as OS. OP is the same length as OS. And OT is longer. And OT is longer than OP. A contradiction. Therefore, there's no such thing as OT, right? This has to be here. I can't draw it here. Therefore, there is no other point T, I'm going to write at the bottom of my board today, and OP is perpendicular to QR. So whenever you have a tangent, it's perpendicular to the radius. It has to be. This angle has to be 90 degrees. Because if the 90 degrees is anywhere else, we get a contradiction. So it has to be right there. And you can use it for things like this. Very simple example. Oh, that wasn't a good circle. $130, and you have to work out this angle. Wasn't a very clear 130, was it? 130 degrees. Well, the tangents are meeting the radii at 90. So I've got 180 left for these two. What's 180 minus 130? Given that, what can you tell me about this quadrilateral?
Shape or?
What can you tell me about this quadrilateral?
Opposite angles are supplementary.
Therefore, it must be cyclic. So in theory, it's possible to draw a circle through those 4 points. Don't know if my diagram's accurate enough to do that. Now, I do know these opposite angles are 90 degrees each. So these are, so that means they're supplementary. So these ones have to be supplementary. So this must be cyclic.